Hello everyone. Today I will be doing LeetCode 83, remove duplicates from a sorted list. This question is categorized as an easy linked list question, and if you're wondering where I got this specific question from, it's from algomap.io's linked list section. What AlgoMap is, it provides a beginner-friendly roadmap for LeetCode style questions compared to like NeetCode.io. So I would say if you're a beginner, start off with AlgoMap and then gradually shift into NeetCode. And if you're wondering, the creator already has solutions posted for these questions, and it's on his YouTube channel. The videos are in Python, so if you want to answer this question in Python, I would recommend you go check out his video because I'm going to be doing this question in Java. But definitely check out this roadmap and the creator Greg Hogg if you have the chance. He's a really talented individual, a University of Waterloo alumni. He provides a lot of great resources for computer science students and aspiring software and data engineers. So, after I cover some of these questions, like beginner questions on AlgoMap, I might also start posting some solutions for NeetCode's roadmap as well. But for now, let's just get started with LeetCode 83 here. And the prompt reads, we are given the head of a sorted linked list. Delete all duplicates such that each element appears only once. Return the linked list sorted as well. So after reading this question, my key takeaway from this question is we're given a sorted linked list, which makes our lives a million times easier. The benefit we get from this question by having it sorted is that we know that the duplicate nodes, the duplicate values at least, will always be right next to each other because if it's sorted, then it has to be next to each other. Also, we can note that we're given the head of the linked list, and we will ultimately be returning the head because they want us to return the linked list sorted as well. But we really know if you have access to the first node in the linked list, you could always traverse it, and it's equivalent to having the entire linked list. So first, let's take a look at the sample input and output they give us. So example one, we have two nodes that have the value 1 and a node that has value 2. We know that this means we must remove one of the two nodes that have the value 1 because we don't want to have any duplicates. And that's exactly what the output is. We could look at more examples, but I feel like from just this one example, we have a grasp of this question. So the first thing I would do, like this is how my brain works, the first thing I ask myself is what are the base cases for this question? Well, we know if a list is empty, then it can't have any duplicates. And the other situation where it can't have any duplicates is if our list only has one element. So these two base cases, I want to keep these in mind when I approach this question if I ever run into any challenges. Now let's jump over and visualize this question and see how we could go about solving it. So let me move these to the side. And we know we will be constantly comparing two nodes that are right next to each other to see if their values are equal. And it might be tempting to create two pointers, but if you keep watching, I'll show you how we can approach this question using only one pointer. And the benefit we get of that is we save some space in memory, I guess. So the first thing we should do is create our pointer node and set it equal to the head. For visualization purposes, I'm going to use this light blue arrow to signify this pointer. So let me put it over the head like this. Now, even while we're doing it visually, I don't want to confuse myself or you, the viewer, so I'm just going to be referring to this as cur, which is short for current. So each node that we're at, we want to check if the cur value is equal to the cur.next value. And for the time being, I will use this darker blue arrow to signify cur.next. At the first iteration, we see that 1 and 2 are not equal, so we can traverse our cur to the next node. So our cur is currently at the node with the value 1, and we could traverse it to the next node, and now our cur.next would be right here. Now when we check if our cur value is equal to the next, we see that it actually is. Now this is really the meat of the problem. What do we do when we find a duplicate? The answer is simple. We will skip the duplicate node by saying our current node.next is equal to our current node dot next dot next. So essentially, we're crossing this node out and we're saying go from here all the way to here. This successfully skips over the duplicate node, which quote unquote removes it from our linked list. So now, after we've done that, we could traverse our cur again, but now our cur.next is no longer this 2, it's actually this 3 right here. So now that we're at this value, we're at this node with the value 3, this should signal something to us. We don't have a node after this, so there's nothing we could compare this node to. This tells us we must be wary of this when we create our conditions for our loop. Now I want to show you another case which presents to us another edge case that we had to be careful of. So what I'm going to do is get rid of this, and I'm going to get rid of this node 3, right? And so let's just imagine this is null. Now our algorithm is going to tell us again, we skip this 2, and we go right here. Now, instead of being at the node that has the value 3, we're at null. So we traverse our cur to be at null. And now this is the second condition that breaks our loop. So if our cur value equals to null, or our cur.next value is equal to null, we know that we've reached the end of the linked list, and there's nothing more for us to keep checking. Now that we understand the logic of this question, let's jump back over to LeetCode and write out the solution. So I kind of want to go line by line of how I was just speaking this out. So one thing I want you to keep in mind, actually, it's a big trick, not a big trick, but a tip for LeetCode style questions, is we're given some comments here that tells us details about our linked list. So definition for singly linked list, we have a list node. So this is important. If we just call this a node, it wouldn't technically be correct because LeetCode is telling us that nodes in this case are defined as list nodes. So I should create a list node, call it cur, and set it equal to the head. Now I'll create the loop that's going to help us traverse the entire linked list. And we discussed that we must stop traversing if cur equals to null or if cur.next equals to null. So when do we keep going? When cur does not equal to null and cur.next does not equal to null. The reason we use and in this situation is to avoid a null pointer exception. And like we discussed in the visualization, every time we're at a node, what we want to do is check if our current value, but now if we check these comments again, we'll see that they're referencing it as val. So we had to make sure we use val too. So if cur.val equals cur.next.val, then what we want to do is update our cur.next to skip that duplicate node. So cur.next.next. And then regardless if this if condition is true or false, at each iteration we must move to the next one, and we do that by saying cur is equal to cur.next. This is just equivalent to us taking cur right here and moving it along the list. And every time we move it, this while loop checks it again to check if we're finding a duplicate at the current node we're at. And essentially, when this while loop ends, we know that we'll have removed any duplicates that already exist. So we could just go ahead and return head. And if we do that and we run our code, we will see that this has been a success. So if this video helped you out, please feel free to leave a like. I would appreciate it a lot, and I want to wish you the best of luck learning.